should be live on YouTube.
Live streaming is on.
Okay, confirm. So, feel free to start whenever you want.
Yes, Walter, you have the floor.
Thank you. Just a
Okay,
moment. I'll
you are
show
the
my.
king for today.
Let me share my screen. Can you see my screen?
Yes, yes, very well.
Perfect. So, good morning, everyone. First, it's a pleasure to be here at this conference, present our research. I hope everyone is well. So let me start introducing myself. My name is Walter. I am from Brazil, where I work as a professor at IFRN, and also I am a master's degree student at UFRN. Now I'm going to present our systematic literature review. The title is Failures Forecast and Monitoring Data Center Infrastructure through a Machine Learning Techniques, a systematic review. So let's start for why we researched machine learning applying techniques, applying to infrastructure monitoring. Mainly because data centers are gaining a prominence as an increasingly critical component, right? Modern data centers are complex systems, and in detail monitoring easily results in hundreds of thousands of items to be monitored. And also, recent advances in machine learning area have been generating unprecedented opportunities to enable scenarios for early detection failure. So, um, what we aim in this study? We aim to review the current state and future trends of the machine learning techniques, focused on early fault detection. And as achieve this goal with a scientific rigor, we conduct or undertake this review as described by Kitchen. So this review was carried out through a mapping of algorithms, techniques, models, and application challenges in this area. And to do this, we follow these four research questions and try to answer these four research questions that I will detail in the next slides. And we start with a search that includes 446 papers. And so we move to stage 2, where we could read the title and abstract of the papers, and had left 53 papers. And then we move to stage 3 of the search, where we conduct the careful reading, and 51 papers. So, as you can see, this figure shows the tendency of increasing interest in this field over the time of year of publication. So, as many results, we answered these research questions. The first one was, what are the main characteristics of the machine learning algorithms and models that are being applied to monitoring of data center infrastructure? The first thing we noticed it was is a wide variety of machine learning strategies and algorithms applied to monitoring data center infrastructure. And the second thing was the random forest. It was more often used. Also, the machine learning algorithms present in this paper were classified in three main categories: and supervised learning, and unsupervised learning, and semi-supervised learning, as shown in this image. Yeah. This image also shows that supervised learning, it was more often applied in the papers included in this research. We also present a figure that shows the main challenge, the main algorithms and models and techniques applied, classified in these three categories. So about the research question 2. What types of data are being used in proposed models? For example, log data, sensor data. And we found that the works in this systematic literature review are really heterogeneous in terms of types of data used to train the models. The main type of data used was smart data from hard disk drives, for example, and log data. And in general, the papers included in this review did not demonstrate that in details the tools used to collect stage of data source for the training. So we show we show this figure demonstrating that we can notice that the three types of data used more often was log data somehow, smart data from hard disks and solid state disks, and performance data as CPU load and memory load. And the third research question answered was, what are the main challenges in applying machine learning data or techniques in data center infrastructure? We classified the challenges in three types. The first one was related or related to machine learning models. And the first challenge was the model aging problem. That demonstrates that over time, the data may change and the model may need to be retrained over time. So the second one, that despite the crucial role of syslog processing, in this case, switch failure diagnosis, detection, prediction, existing syslog techniques have low accuracy. And the second group of challenges was named complexity, or challenges related to complexity. The first challenge was that the large amount of information in syslog data make it difficult to find the right pattern. Also, complexity failure, also the complexity of find the failure or root causes. It is a big challenge for the context of failure detection. Another problem in this context, or complex problem, can have various data sources in IT stack. And also in majority types of challenges related to disk hard drives, it is a challenge called the heterogeneous minority disk report. And the last group of challenges was called missing data, or challenges related to missing data, where we can see it. Transient failures such as processor and memory overheat are persistent. The impracticability of collecting specific level data events from inside of the data center. Also, a lack of standard of smart data.
QGIS and PostgreSQL methods are
And a blackout of monitoring data. Also, in the context of disks, no label indicates what disk was replaced when some disk was replaced in the works. So we present this image resuming the main types of challenges grouped by type. And the last research question was, what are the most common type of failure identified in the data center infrastructure monitoring? So we grouped the types of failure in the following areas. specific hardware failure, general hardware failure, where it includes hardware failures, firmware, software, and application firmware failures in general way, network failures, scheduling failures, and software failures, and safety level failures. So we also group the frequency of this failure, and as we can see, the majority of the studies focus on hardware failure and general failure. So, as a conclusion, future works, we can show this SLR has discussed 51 papers, unique, published between 2009 and 2020. Most of the work was applied to supervised learning. The main types of data used was smart data and log data, and the main types of failure was hardware failures. The heterogeneity of the studies with respect of data source and strategies made this data synthesis process challenging. And these studies have identified an increasing interest in and suitable failure prediction strategies based on machine learning techniques. Also, there is no consensus on the strategies to be adopted to anticipate monitoring failures in more general way. Observe, in which most of the papers focus on some subsystem of the data center in a specific way. And as a future work, we will use these insights to identify in this review as a basis for the development of a predictive monitoring platform for the data in the data center. This is the reference, and thank you for watching. Any further question, I open to answer.
Yes, what are your major findings?
Sorry?
What are your major findings?
The main findings are about the main challenges targeted by the researchers, and the main types of failures. We notice the main also the main algorithms applies for for each type of failure and each type of challenge, right? So in general, the papers focus on a specific problem. It's more challenging, target a broad type of failure, right? And the main root cause of the failures was related to hardware failures. It was one of the findings.
Okay. So, what do you suggest that after this study, what are you going to do it?
We are going to develop some kind of model and then a tool to target this kind of failure that was more frequent a root cause of failures in data centers, that was hardware failures in general way. And to do this, we use the insights from this systematic literature review as a basis.
Okay, so what do you suggest to the authors to do a future work in something you want to suggest?
As future work, where the authors could search the specific types of failure for subsystem, because we notice in this research that the heterogeneity of the works cause the nature of the problems and the nature of the types of data. So for each type of subsystem, the authors, some group of authors could focus as hard drive failures, for example. It was necessary to do the same kind of research, but in a more specific way for these targeting these subsystems.
It's good. It's good to nice to hear. Any questions from the audience? I can see some of them. They are also present. Idris is there, and some other fellows are also there. If you have any questions, please. Floor is up to you. So, thank you so much for your first presentation.
Thank you. I will close my screen share.
So, the next presentation is, I think, in absence of the paper number 2, the Himanshu is going to present, right?
Yes, sir. Am I
Himanshu, where
audible?
were you since morning? You are coming at exactly at the last time.
I apologize, sir. I have been actually I'm sick for some time, so it was slightly difficult for me to join since the morning.
It is not morning, it is morning here, but I think it is in India. It is
Yeah, in
already,
India it's 1 o'clock,
it is
sir.
1 o'clock.
Yes.
Yes, okay. So go ahead.
Yes. Am I audible?
Yes, you are audible. You can also on your camera.
Yes, sir. Yes, sir. Uh, is my screen visible?
Yes.
Okay, sure. So, good morning to all of you. So I will be talking about empirical methods of effectiveness of an NLP method for predicting code smell. So this work was done by me, Abhiram Gulanikar, Dr. Love Kumar, and Dr. N.L. Bhanumurthy. Abhiram Gulanikar is my fellow batchmate. Dr. Love Kumar and Dr. N.L. Bhanumurthy are professors, and all four of us are at BITS Pilani, Hyderabad campus. So before starting the presentation, I would like to thank my university for providing us with this opportunity to present the paper. I would also like to thank Professor Sanjay Mishra for giving us the opportunity to present our work in this conference. Also, I would like to thank Professor Lav Kumar and Bhanumurthy for their guidance, insightful comments, and helping me with the experiments. And last but not the least, I would like to thank uh, my parents. So, what exactly is code smell? Code smell is a quantifiable metric which indicates severe problem in complex software development lifecycle due to poor programming practices. Now, what do I mean by poor program practices? It basically means that some of the practices which which hinder the code's reusability, expansion, and basically do not allow other developers to take on the work and expand the work on this particular code base, and hence it does not allow the software to expand very properly. So one of the very easy examples which I can give is blob code smell. Okay, so what typically we do is we write all the when we write a class for a Java, let's say we write a class in a Java function, we write all the functions, all the feature, all the variables in that one class, and then we import the entire class everywhere. Now that practice is not particularly good because that practice will not allow the class to expand, and that particular class can be bifurcated and can be used and can be if it can be maintained in a much better way if we are getting in a if we are maintaining smaller classes. So it does not basically always means that there is a problem with the source code, but it just reflects the poor quality of work that has been done. This problem is very important to solve because as our industry is heavily reliant on software and code bases, maintaining and expanding software becomes more important. And that is why code smell detection is one of the key problems that we plan to solve. Now, coming to related work. Now, Com et al. Explores the connection between code smells and change proneness in classes. Now, the conclusion of this study indicates specific code smell adversely affect the maintainability of source code. Just just by the last example, blob code smell is uh, one of the one of the classes. Now, Coleman et al. Demonstrates how software-related decision can be benefited from automated software maintainability analysis. Now, Francesca Montana et al. Compared 16 machine learning algorithms on 4 code smell. Now, they found out that random forest performed the best while SPM performed the worst. But these papers do not particularly talk about how these code smells are detected and what kind of features are we using for detection of code smells. Now, this is where our primary study lies. What we aim to do is identify NLP techniques which which are responsible for generating from which we can detect code smells. Now, based on a given set of data set, based on a given data set, we need to have data sampling techniques as well in order to understand what sort of how data imbalance and other issues in data can be handled. And last but not the least, we will be using extreme learning machines and their different kernels for their classification. Excuse me. Now, coming to the experimental data set. Now, we did our experiment on 629 open source projects that were available on GitHub. The dataset consists of lists of packages along with their corresponding code smells. Now, these are the following code smells that were present: Bob, complex class, internal getter, leaking internal, long method, no memory resolver, memory memory method, and sysarmy knife. For understanding all of these methods, please go into my paper for all the details. They are described in depth in the publication. Sorry. Now, coming to the research framework, our research framework is fairly straightforward. So from the original data, we have the original data. What we mean is the 629 open source packages and the user comments and the code smells that are present. Now, from the user comments, we extract a vector of dimension 300 using scriptgram and continuous bag of words. Now, based on these methods, we get a feature vector of 300 size, and then we have 300 vectors, and then the final data output will be of 8 classes as described in the previous slides. Based on the data set, we have feature selection techniques, whether all features should be used or only significant features should be used. After that, data normalization is done, and finally, ELM methods are there for classification. So there are uh, three basically kernels used, which I'll go into detail: linear kernel, radial basis function kernel, and polynomial kernel. And for validation, 10-fold cross validation is performed, and then we check the performance of each of the method that were present. Now I'll go into each of these into details. Uh, Firstly, we'll come to feature generation techniques as it's the first step. Continuous bag of words makes use of surrounding words to predict the current word. Since it derives from bag of words, words present in the window are not differentiated based on current word's distance. Excuse me. I'll take a pause here. Any doubts so far?
It's okay. It's okay. Go ahead.
Yeah, sure, sir. The script bump model makes use of current word to predict the context. Hence, words nearer to the more heavily weighted words are weighted more than the words farther from the present words. So these are the two techniques which are present. For reading about these two techniques in detail, please go into the publication. They are explained in detail over there and how we are using them. Now, once the feature vectors are generated, we make the use of data sampling techniques to ensure that the data offset is not too much in the class. So I'll just show here the experimental data set. If you can see the table, the table in the slide, the the smelly percent and the no smell percentage are highly imbalanced in many classes. For example, if you can see, blob classes has just 37%, and no smell and smelly percent is 62%. That is a huge imbalance. Then again, SAK class has 73% of no smell percentage, and smell percentage is just 26. So these sort of imbalance creates leads to poor performance in prediction of code smells. So to encounter these, we ensure that we are using different sort of sampling techniques. Now, Smote and borderline Smote use k nearest neighbors, but difference between Smote and borderline Smote is basically borderline Smote generates external additional data points based on only along the given class's boundary. It does not generate a data point which is beyond the class boundary. So there is no external bias. SVM Smote uses simply support vector machines rather than k nearest neighbors to generate samples for and the between the samples and the decision boundary. So these are the references also provided for each of the techniques. You can also read the paper for them. Now, feature selection techniques. Wilcoxon sign rank test is used for statistical significance between different software metrics. We reject the null hypothesis if the p-value of the test is less than 0.05. For reading more about p-value, please refer to the paper. Cross correlation analysis is used for selection of independent variables that are highly correlated to the dependent variable but are uncorrelated with each other. So these are the ones from which we select features out of the given 300 dimension vectors. Again, again the reference is given for the readers to understand which are the what papers can be read for this. And again, viewers can refer to my paper also. Now, finally, coming to the ELN. Now, extreme learning machines are simply feed-forward neural network, and they can be used for any task in which a simple neural network can be used for, like classification, regression, and clustering. Kernel functions are just mathematical functions used for transform training data into higher dimension. Now, this is done because as we transform data into the higher dimension, we have more and more features from which we can get the output classes of 8 classes. Now, when we have higher classes, this becomes slightly computationally more expensive to train, but slightly more
Sorry,
computationally
sorry, I'm
expensive.
sorry.
Yeah, yes, sir.
No, we are sorry. We are extremely sorry. I don't know that. It's okay. Go ahead.
Sure, sir. Kernel functions are just mathematical functions for transforming data into higher dimensions. Now, we have performed our experiments on 3 types of ELM kernels. The linear kernel is generally chosen when we are dealing with data which have linear dependency with the output class. The radial basis function is a non-linear kernel used for training SVM, generally used for training SVMs and solving non-linear problems. By linear and non-linear problem, I just mean that training the input features and the output features should have some sort of a linear relation between one another. So by linear relation, I mean y is equal to w1 x1 w2 x2 w3 x3, something like that. So each of the exponent of the input vector should not be having a polynomial power. Their power should be one. Very simply meaning, polynomial kernel is used for training non-linear models. It is faster and requires fewer sources, but in theory, it is less accurate than RBF kernel. So, coming to our results. So, I will only talk about accuracy. Uh, we have compared our results across 3 metrics: AUC, accuracy, and F measure. For all three of them are present in my paper. You can go into details. So coming to the first figure, all metrics and significant metrics, as obviously predicted, all metrics will perform much better than significant metrics because more number of features will lead to better performance. Very simply put. Now coming to the second figure, we have original data generated using Smote, data generated using borderline Smote, and data generated using SVM Smote. Now, if you can see closely, the numerical figures are there in the paper, but if you can see very closely to the figure, you can see apart from original data, every other data set is performing almost the same, and produces very high accuracy. Now coming to the extreme learning machine performance. Now we can see linear kernel performs very bad with the median in 70. RBF performs slightly better than polynomial kernel, if you can see. Now, answer to the research questions. These are the research questions as earlier discussed. So, continuous bag of words performs slightly better than skip grams across accuracy and F measure. The F measure metric has not been shown in the slides, but you can again refer to the paper. They are described in table 6b of the publication. The ability of data sampling techniques to detect code smell. So although all three as shown in the figure, all three performs almost the same, SVM performs the best. The numerical figures will be given in the publication. The ability of different ELM kernels to predict code smell. RBF and polynomial perform much better. Like very simply put, their performances vary across different measures. Like in accuracy, RBF perform better. F measure, polynomial perform better. So that is why we can't say there's a very clear better method in this. But if you want to go into more details, they are very properly described in section 5 of the publication. In conclusion, continuous bag of words performs better than skipgram. SVM performs the best. Models based on all metrics perform better than significant metrics using the Wilcoxon sign-rank test. And RBF kernel performs the best among the ELM kernel. We are saying this based on accuracy. Now, future works will include using trainable parameters in the feature generation methods as well. So now we are using continuous bag of words and skipgram. We can use BERT embeddings, FLAIR embedding, which in itself are trainable to get even better embeddings and perform better when training with a neural network, any sort of neural network, ELM or a normal RNN or LSTM otherwise. This brings me to the end of my presentation. For any questions, please contact Lav Kumar sir. Sorry, or me. For any doubts, we'll be very happy to answer you.
Any question, please, from anybody? I'm really sorry. Just to please.
I'm sorry, sir.
No, it's okay. Okay, what happened? I hope you have taken the vaccines, the other issues, right? It is viral
Yes, sir,
fever. It is viral, right?
I hope the same, sir. Yes.
So how many days you are suffering?
Sir, 3 actually. It started since Friday.
Okay. Andrea, you don't need to wear the mask because it is online.
Sorry, I had the microphone muted. I have to wear the mask because there is the chance of people coming in, so I have.
Okay. It's okay. I thought that you are fearing from us. No, right.
So, is there any presenter for the next 2 presentation of this session?
I can't see anybody. Anybody is there?
Right. The presentations by the title. Let me see.
Saida Hussain. Saida.
Because we skipped the first 2 presentations, if I am correct.
Yes.
So
First 2 presentation, yes, and the last 2 was presented.
perfect. Did you receive the link that I sent you, sir? Did you see that? I sent you the link for the form that you have to fill after every session in the private messages here on Jitsi.
Okay, I have chat. Okay, something is there.
Okay.
Something, yes, I don't know. Whatever is this one? Open chat and something. I couldn't see it. Enter into the room.
Sorry.
Yes, I saw it.
Okay, perfect. Thank you. So if there is no one that can present for the first two presentations, may I suggest we skip to the next presentations if someone is here, so we can.
But I don't think that anybody is here, right?
Oh, I don't see any name corresponding to the schedule.
Hello, I'm Yusen. I think my presentation will start. Okay, my presentation is in section 2B.
Section
Okay.
2B in, say, in the same room, room B.
Yeah, in same rooms, same 2B.
At what time?
At 10:15.
You can present now. There is no any issue.
Okay.
Means 10:15 is okay. You okay? Machine learning applied for the spectra classification, right?
Yes, yes.
Okay, so okay, you are from the. I can see the Peter is there from Hungary, right?
Yeah, from Hungary. Sorry,
Hmm.
something is wrong with my computer. I cannot. Okay, now you can see my screen, right?
Yes, we can see the Hungary. Mhm.
Okay, I start now. So, my name is Yue Sun. I come from University of Zagreb in Hungary, and I do my research work at the European Expert. Today, I will present our conference paper, Machine Learning for Spectral Classification. In this work, we applied several popular machine learning deep learning models for the spectral classification. Our dataset was collected during HED high energy density experiment. And in HED experiment, the the change of pressure will cause the change of the spectral peaks. And the two major spectral peaks we aim to capture are the change of the intensity distribution or the shift of the peak positions. We aim to we aim to find a position point during the experiment, which also means to classify the spectra into two classes corresponding to the low pressure and the high pressure. The spectra marked in red and blue are the representative spectra used for training during the supervised deep learning models. And as you can see, the number of spectrals, number of the features is much greater than the number of training examples in our dataset. That we apply principal component analysis for the dataset pre-processing to reduce the dimensionality of the dataset and to prevent overfitting problem. Before applying PCI, the dataset should be centered by remove the mean, and the centering is performed independently on each feature. Here is an example after remove the mean. And in PCA, the number of principal components can be determined by the cumulative explained variance ratio, and as shown in this figure, we also show the value distribution of the new projected pieces. From this figure, we can see the first pieces explain the most variance with subsequent each subsequent one explaining less. And the first two pieces can already explain more than 16% of the variance, and the 13 pieces can explain 99% of variance. And when transformed back to the original space, we can see the information obtained or lost by the new selected pieces more clearly. The two pieces can capture the basic shape of the original spectral curves, but with more pieces, it can show more details. So in our work, we select 13 components. We also analyze its loading metrics and also contribution of each original variables to the new selected pieces. From this figure, we can see the more obvious the features, the great contributions to the new selected pieces. And here is the classification models we applied in our work. It including to supervise the deep learning neural networks and also a clustering method. In the first module, it is based on LSTM, which is one of the recurrent neural network. We applied a single layer for our classification task. And the second is a transformer-based model. It is a self-attention-based network, which was originally used in natural language processing. Here we adopt its encoded part and discard the positional embedding step. And for the decode part, we apply a dense layer with sigmoid as activation function for the classification task. In these two models, we did not consider the connections between different spectral curves at different time steps, so just consider the interconnections of the features. And the reason we chose the spectral clustering model is because it is very suitable for the dataset with non-flat geometry, and only need to be divided into a small number of clusters. And here we show more details of the implementation during the LSTM and transformer-based model. Here is the training dataset. It consists of the original dataset after PCI preprocessing, and also some simulated ones by adding some random noise. The notebook is available at this website. If you are interested, you can take a look. And we also list the optimizer, the loss function, and also the GPU we are using during the implementation. As there is no ground truth information, we are interested in if there is a clear boundary or ambiguity zone, which during the experiment, when the classification level jumps inconsistently during among the phases. So we propose to use classification confidence, which to show how small this ambiguity zone is. If there is no boundary detected, it means all the spectral curves are classified in the ambiguous region, and the corresponding confidence is 0. And if a clear boundary is detected, it corresponds to 100% classification confidence. And here is our classification result. All three models can achieve 100% classification confidence, while the clustering method consumes the least calculation time, and the transformer-based method consumes the most training time. And for the spectral clustering method, we also test its performance on the different number of pieces or different cumulative explained variance ratio. The results show that it can always achieve 100% classification confidence, and the boundary it detected is also very stable, only fluctuate within a small range. Above is our work presented in the conference paper. In the future, we will conduct further research on the end-to-end machine learning deep learning algorithm for the spectral classification, and we will also apply the models implementing above to two-dimensional diffraction images. Yeah, thank you.
Well, any questions from the audience? So I have a question. What is your major findings in your work? Can you summarize the major findings?
I think our main findings is that for the actually using the unsupervised spectra is also very fast to classify the spectral data, and by using the deep learning models, it is for the spectral for the LSTM and the transformer model, which was originally used in natural language processing, it can be extended easily to the one-dimensional time series dataset.
Okay, so what do you think that what are you going to do in the future?
Currently, we are we are conducting some research work for the end-to-end deep learning models. We applied a convolutional neural network or ResNet or some other deep learning models to test its performance from different perspectives. And our next step is to apply the end-to-end deep learning models to the two-dimensional diffraction images.
It's okay. Any other questions from anybody? So in absence, it's okay. Is the next presenter Michael? It is the 10:30. I think it is still half an hour is there.
Okay, thank you for your question. Now
Thank
let's
you.
start sharing.
Please.
Okay, so is there any other presenter here in the room? Because we have officially a break time now until 10, a quarter past 10. So if you agree, sir, we can.
It's okay. Disconnect for 15 minutes.
Yeah, so we can wait and hope that some other presenters join us.
But I think you should on it so other can join as well.
Sorry, can you repeat, please?
No, I think do not be off, because once you becomes off, the guys may not join, right?
No, I won't go off. I just take a break here. So
Yes, it's okay. It's okay.
The room stays open.
Yes, room is open, and it is, I think, say Patu is starting at 10:15 and first presenter has gone. So it is the second and third we are waiting for, right?
Yes.
It's okay.
And eventually, if the first two presenters from today morning join us, we can make them present. If
Yes,
you are...
yes. Anybody is coming? No problem.
Okay, so we go on a break until 10:15.
It's okay. It's okay. Thank you.
Thank you.
Streaming is on.
It was nice.
He hasn't played.
Yes, he has replied something.
Okay, yeah. Okay. Okay, good. It's the one. You see. Okay, but my slot is 9:45. Okay. Maybe it's just trying to make it.
No, but you must be present in your session.
Yes. This past 9. Maybe before that. Available. That's good.
It's okay. Let me do, and until 3 days now we are going to.
Okay. Okay, that's the conference.
Yes.
3 days. Wow.
3 days.
Too much.
It's okay. Up to the 6, 5, 6.
So we can start the next session.
But the first presentation is already done.
Yes. So if there is any other presenter, we can start. Otherwise, we can stay on a break until someone join us.
Is on.
Is anybody present now? Yes, Suza is there. Liza Souza is there. Yes. So she can present now. Can you hear me? Souza, Liza.
Hi, good morning. I'm here.
You are here, right?
Yeah.
Can you on your camera?
Hi.
Can you on your camera? Can you on your camera? Are you ready? Liza, are you ready? Liza, are you ready? Andrea.
Yes. So I see that Liza Souza is online, but she has the microphone muted. So probably she's trying to connect. I see also Let me check the schedule. No, I was sure that someone else was joining us. I've seen a webcam popping up, but we should wait, I guess.
Excuse me, what happened to the previous talk?
Which
So
one?
it has already been done.
The one
It has already been done.
machine learning applied to spectral classification.
Yes.
But wasn't that at 10:15?
Yes, but they have presented in the previous one. Yes, she has presented.
But it's now 10:19. How is it possible to present in 4 minutes?
Everything is possible. If you are present, you can present it now. Lyse, please present.
She's on chat.
Good morning. I'm here. Can you hear me?
Yes.
Now we can. Perfect.
Okay.
You can present now if you want.
Good morning. My name is Laís. My affiliation is the Federal University of Sergipe, Brazil. Today, I will present the article Design of Smart Cities Dimension using the Smart Cities ML profile. Modern life in cities is highly dependent on infrastructure that are crucial to the daily activities of citizens. Smart city refers to the search and identification of smart solutions that allow modern cities to improve the quality of services provided to citizens. The proposal in this article is to adapt and extend the Smart Cities ML profile to identify the dimensions of a smart city and improve the focus on problem solving. The dimensions proposed in Smart Cities ML profile can be used to identify and describe essential characteristics and factors for a smart city, improve the efficiency, sustainability, and quality of life of citizens, ensure the city's development for present and future generations, and expose the application needs and elements of the application model area in smart cities. The Smart Cities ML profile dimension is organized into people, governance, economy, mobility, environment, and living. The people dimension refers to inclusion, education, and employment, with values such as equity, creative innovation, and flexibility to identify and modeling solutions. The economic dimension refers to enterprise and innovation culture, productivity, and local and global connections, such as characteristics to prove new business modeling and increase economic growth. The mobile dimension refers to infrastructure, efficient transport, and multimodal mobility to facilitate the flexibility of people within a city and generate benefits such as reduce pollution and increase safety. The governance dimension refers to administration, infrastructure, public services, and open data to help in urban planning, decision-making, and transparency to citizens. The environment dimension refers to the care of natural resources and planetary cultures, such as sustainable building, resource management, and sustainable urbanism. The living dimension refers to entertainment, safety, culture, and health as a way to improve the quality of life of citizens. Smart cities ML profile dimensions makes it easy to use the common elements of smart city dimensions through visual representation. The conception of this extension arose from the need to think in different dimensions to separate interests and improve the focus on problem solving. And during the elaboration of the design, some challenges arose related to formalism and consistency between the diagrams, mainly due to the lack of software tools that can fully implement all CSML resources. The table illustrates the different dimensions described by various authors. The authors of dimensions are horizontal, and the dimensions are vertical. In this table, it can be seen that most are not yet consolidated. For example, the people dimension is presented in Smart Cities ML, GG, and NP. The governance dimension is presented in Smart Cities ML, GG, and N. The technology dimension is presented in NP, R, N, and G. And the other dimensions are presented only once. This article is different from the articles illustrated in the table by includes characteristics and factors for smart city dimensions as native components of CSML and adapting the language to represent the elements using terminology now to stakeholders. Model systems for a smart city is a complex activity, so there is no single standard to be used. Since there are many model languages, the objective of this article was to adapt and extend the Smart Cities ML profile to identify, describe, and model systems for the various dimensions of a smart city based on essential characteristics and factors in the quality of life of citizens. Future work will focus on software modeling and simulation of various case studies of smart cities related to infrastructure systems, for example, traffic signal control, water and sewage treatment, energy, and health information systems. Thank you.
Any questions, please? Any question, please? Okay, so what is the conclusion of your work, Lisa? Liza?
I'm
Sorry.
here.
Yes. What is the contribution of your work? What is your major contribution?
Can you repeat the question, please?
What is your major contribution in this work? You understand?
Yes.
What is? Please tell them.
My conclusion is that this work can help in infrastructure modeling of other case studies for smart cities, for example, water, treatment, energy, and the others.
Well, any other questions from anybody? What are you planning for as a future work?
I have a question.
Go ahead.
Okay, I think a brilliant presentation. My name is Kennedy. I'm calling from Nigeria. I have a question for the presenter. I would like to know the component elements that aggregates data for this smart city CML profile. I want to know the component elements, especially as regards data aggregation for possible analytics. Hello, did you hear my question?
Let's say, please.
Did you get my question, Santos?
Can you repeat, please?
Okay, my question is this. You're talking about smart city. I want to know the component elements responsible for data aggregation for possible analytics.
Oh, okay. It is
Yeah, because you're talking
about the components.
I said my question is based on the fact that you are talking about design. So if you are talking about design, I want to know the constituent elements, the components that could possibly help in aggregating various data for possible analytics. That's my concern, please.
Yes.
What, yes, you understand or not? You understand the English what the Kennedy is asking?
I hope.
I think because of the Portuguese language, she are not able. Maybe she is understanding, but she is not able to reply.
Okay. Okay. Okay.
And Michael is not there, right? Or Michael is there?
Yes, I'm here. Good morning.
Yeah, Michael, please go ahead. You are a very good friend of mine, right?
Maybe I could also could not understand very well the question, but I may try to explain. We are basically using SysML as a basis for constructing this profile, and then this is the first step. Then we are planning on applying this profile in a series of case studies, and then we can think that we can provide some data, and then we can provide some data for analytics. That's our idea. But I'm not sure if I could answer well your question. If you can,
Kennedy, if you have, please ask.
I'm just trying to understand how the data aggregation happens within this model for analytics.
Yeah. What do you mean by data aggregation?
That is collection of data, collection of
okay.
different, yeah.
Okay, understood. Yeah, that's what I mean. We first provide this profile, and then we are starting to apply it to some case studies. The issue here is that we need to go to the city hall and talk to many people and ask them to use the profile in a series of case studies in traffic, for example, road traffic management systems or energy distribution. That's our difficulty right now. That's what we are planning on. But I agree with you. With lots of data, then we can maybe next conference we can present a new paper about this profile.
Oh, I see. I see. Okay. Okay.
Are you satisfied, Kennedy?
It's an ongoing research, so I think I'm satisfied. Probably subsequent work might have more details. I'm okay. Thank you.
No, if
Thank
you would
you.
like, we can provide you the more papers, because in fact the Michael is also my collaborator since long time. We are working on system modeling, so we have also developed some of the languages, so we can provide some papers. I know you are very interested, so there is no any issue, right?
Okay. Okay, Prof. Okay, thank you. Thank you.
Okay,
Thank you for
thank
your
you for
question.
coming.
Okay,
Thank you, Michael.
Okay, no problem.
Yes. So anybody else who want to ask any question? Leslie has one more presentation in the next session. If she wants, she can present it now because Michael is also there.
That would be perfect if she's ready. Thank you.
I'm sorry, but you are not following the schedule, right?
No, I'm following the schedule because it is a combined mod. It is a online and it is offline. So somebody is not present, so you can present if you like. It's okay. You are welcome into the next session. No issue.
Okay.
Don't present it. Don't
Yeah,
present
but
it.
I missed the first talk. I wanted to attend the talk, the previous talk, and when I arrived, it was 10:15, and it has already
She
been
has
done.
no. Try to understand. If anybody is present and he is ready, he can present. So the first
No, you should
presentation.
follow. Sorry, but you should follow the schedule so people can go from one presentation to the other presentation.
It's okay. It's okay. I got your point. Thank you for your suggestion. Thank you.
It's okay. Anyway, the presentation was recorded on YouTube, so you can actually go to the channel of ICCSA on YouTube and see the presentation that was anticipated.
Yes.
It's true, but if I wanted to interact with the author, right, I cannot do that on YouTube. That's the point. I mean, if I want to questions, I cannot ask in YouTube, and I could have
Yeah,
asked.
okay. It's okay. It's okay. I understand your point, right? It's okay. Please be present. If the author will come, he will present in time, right? I understand your point. No problem. So we have time up to the 10 minutes because Liza has presented. The first one has presented, and Jonathan Ape is going to present at 10:45 after 9 minutes.
So, is there anyone for the next presentation here in the room? We have at this time scheduled a scalable blockchain implementation model for nationwide electronic voting system. Is anyone for this presentation in the room?
Which one?
The third presentation of this
Blockchain. No, he will come.
It's scheduled for 45 past 10, and it's almost that time. So if we can